Hi, this is Brendan Devine, CTO of Solesca. Just wanted to give you a quick walkthrough of our software before you begin using it personally, but first wanted to thank you for choosing Solesca. We really appreciate your business as we look to advance the future of agrivoltaics. And at any time, if you have any questions, comments, or concerns, please voice them to me either via email or through our contact form. So with that, let's get started. So the first step is to go to app.solesca.com. So that's app.solesca.com. So I've entered my login credentials here, click sign in, and that will take us to the user dashboard. So this is where all of your previously saved projects are stored. So you can see I've created a lot of demos in the past. We can toggle between a grid view and a list view. And in the upper right hand corner, if you click the question mark icon, that will pull up that contact form I was referring to. So here you can request a feature, report a bug, leave feedback, really anything. This goes straight to my email, we really appreciate any feedback, so please feel free to use this as much as you like. So I'll create a new project here. Good first practice is always to name and save the project first. So in the upper right here where it says untitled project, I will name it Solesca Demo, and with Control S, we can save it. You can see that it updates the last save time in the upper right, so that indicates to us that the project has been successfully saved in the cloud. We can also go to the Save tab here on the left, click Save, and it will accomplish the same thing. So the first real step here is to define the boundary of the plot of land on which we want to develop. So that's accomplished by clicking the Boundary tab here and placing these boundary markers around the plot of land that we want to develop. And as I'm doing that, you can see that it's infilling a demo of solar panels. So this is just a default configuration. We can alter the settings of that later, but we can go in. If we want to add more markers, we can simply click at any point and it will add and live update the boundary. We can actually double click on a marker to lock it in place so that we can't accidentally move or delete it. And to unlock it, we just double click it again. You can see when it's unfilled, it's unlocked. When it's filled, it's locked. And to delete a marker, we can right click or click with two fingers if you're using a touchpad, and it will delete that marker. On the right here, we have the boundary console, so we can set, or rather we can see the boundary area and set the boundary units, and we can do the same thing for the perimeter. We can also change the styling of the boundary markers and the boundary infill. We can change the opacities. We can even make it invisible if we like, so we can just see solar panels there. I'll leave that so you can just see the boundary markers. We could also clear the boundary. It'll prompt you if you want to do that because that is an irreversible action. Next up, if there are any obstructions on the plot of land, we can demarcate those with obstruction markers. So currently you can just create one obstruction at a time, but we're working on a second version which will allow you to add multiple boundaries and multiple obstructions. So I've just created an example obstruction here in the middle of the field. Again, we can change the styling, clear the obstructions if we want to. Next up, let's go to the Layout AI tab where we can configure these system parameters. So this is things like the type of PV module you're using, as well as the overall configuration of the system. So if we want to vary the dimensions of the module we're using, for example, we can click the arrows or type in a number, and you can see that it updates the layout of the solar panels real time. If we want to adjust the tilt, for example, you can see the module is getting slightly thinner. It's kind of hard to see there, but perhaps a better example will be adjusting the azimuth angle. So you can see as I make that azimuth face more southwest, you can see that the modules are tilting towards that direction. And if you notice in the bottom, or rather just middle right here, we can see the DC system power is updating real time as we adjust the configuration. So you can see as you play around with the configuration how the rated power of your system is adjusted. Then going on to the system area down here, we can adjust the hub height, so the distance of the modules off the ground, inverter efficiency, number of modules in an in-portrait configuration. So if we knock that up to 3, we can see the rows get a little bit thicker since you have 3 modules stacked on top of each other. We can adjust the number of modules in a string. So this is based on your inverter sizing. So as we increase that number, you can see the modules getting more blocked together. And actually something I want to do is change the fill opacity to 0 here, just so we can see just the modules on the plot of land. So going back to the layout AI, we can also play around with the row spacing, so we can increase the row spacing. This is especially important considering the type of machinery that may be operating on this agrivoltaic system. So this row spacing, everything here is defined in meters. So 12 meters, we're looking at a little bit over 40 feet there. So that's a good amount of row spacing, but we can adjust that as we like. And you can see as you change that ground cover ratio, the DC system power over here adjusting real time as well. The string spacing is just any distance in between those groups of modules, those strings, and you can enter different tracking axes as well. So with that, we can go to the irradiance tab. So this is where we can either select module irradiance, so essentially simulating the amount of energy output of our PV system, or we can choose inter-row irradiance. So that is actually to simulate the amount of sunlight that crops are receiving. So I'm just going to go ahead and save this project again, just as a good practice, get in a habit of that. So first step here, let's just go to the modules tab, select a start date and an end date for the simulation. So I'll just make it about 2 weeks here, just so you can see what it would look like for a short period of time, the estimated energy output of the system. So our simulation just finished running, and we're looking at about 316 megawatt hours over this 2-week time period, and it also estimates the revenue. So moving on to the inter-row tab, this is one of the really unique features for simulating agrivoltaic performance. So if we choose a start of season date, so let's say sometime in the spring you plant your crops and you harvest them maybe sometime in the fall here. Once we click simulate, this will actually run a simulation using local irradiance data to calculate the amount of sunlight, specifically what's known as photosynthetically active radiation, that the crops are receiving over that time period. So the simulation just finished running there. I clicked open 3D view, and we are presented with this graph here. So as I mentioned, this is photosynthetically active radiation with units of photosynthetic photon flux density measured in micromoles per meter squared per second. On the y-axis here, we have the distance from the rear of the module in meters. So essentially just that inter-row spacing on the y-axis here. And on the x-axis, we just have the hour of the day. So if we look at it in the YZ plane, I believe, or XZ plane rather, we can see that you have this spike around noon. Of course, you're getting the most photosynthetically active radiation, and it tapers off earlier and later in the day. If we look at it from an overhead view, you see something really interesting here. So we're getting this kind of conical shape, which is denoting essentially the amount of sunlight. So let me back up here. If we're looking at it from this x-axis here, the width of this reddish orange part is essentially the cumulative amount of sunlight throughout the day, average over the entire growing season of the crop, that the crops are receiving. So the wider the cone, essentially, the wider this red-orange area, the more sunlight the crops are going to be receiving, and it can be reasoned that the taller they will be growing. So closest to immediately behind the modules, we can see it's a pretty thin distance, which means that the crops are not getting a lot of sunlight. But as we back up a couple of meters, the cone widens out and then holds that width pretty consistently past about 3.5 meters behind the row of modules. So that can be a quick estimation for where it would be beneficial to grow crops. So about 3.5 meters onward, you're going to be getting pretty full illumination. But since it's kind of tapering off here as you're getting closer to that next row of solar panels, might not be the best place to plant crops. And again, this simulation will change based on the inputs that we put in the layout AI here. So this is all based off of the system inputs you've entered here. We also have substation data for US counties. So we can click find, and it will quickly pull up the nearest 10 substations to this parcel of land. So I can go in here, zoom in on the closest one, click it, and we can see all of the relevant data for that substation. So the max voltage for this line is 69 kilovolts. There are 2 lines there. It gives you the latitude and longitude coordinates. We can also remove substations here if we don't want to see them anymore, or just clear them altogether. Next up, well, we've already visited the Save tab. The Report tab is going to be coming in the next version of our software. So that's where we will actually generate reports both for the developer and for the farmer/landowner, more as proposals for the project. Couple of other things. We have databases specifically for farming. So you can see on the left here, we have this crops database and this machineries database. So the crops database is based off of USDA data. So we can select, let's say lettuce, whatever crop is being grown on the land, and this just serves as a quick lookup for the shade tolerance for that crop. So we can see here lettuce is listed as a shade tolerant crop. So shade tolerance is of course something that is very important for agrivoltaics. Combining this with our irradiance simulations for inter-row spacing, we can figure out what a decent crop would be to grow on the land, or whether or not a certain configuration would be beneficial for a certain type of crop. So since lettuce is a more shade tolerant crop, it can stand to reason that it would stand a bit more shading in that inter-row irradiance simulation that we run. So a couple of other growth requirements are up here. So the mature height in feet, so lettuce only about a foot tall, that can help you determine that hub height, so the distance off the ground that the modules need to be. It can also help you set the active growth period, the growing season, when running those inter-row irradiance simulations. So lettuce is typically grown in the spring here, so you could set a date range in the spring for when you're growing or simulating the inter-row irradiance. Going to the machinery tab as well, we can select any type of John Deere equipment. So there are over 350 pieces of equipment in this database. So this can be a very quick lookup for if you're working with a farmer to see what type of equipment they're using and to figure out the working width for whatever equipment is on the plot of land. So for example, let's say they're using this corn head here, which has a working width of 5.7 meters. We can go back to our layout AI here, add a bit of safety tolerance on either side, and we can determine we would need about 10 meters of row spacing to sufficiently accommodate that piece of equipment. So that is our initial offerings. We are currently working on a second version of the software that will be released hopefully end of this year, potentially early next year. So that will have a lot of major improvements to this current version. But please, as you play around with this, let us know if you have any feedback, comments. We really appreciate anything. If you run into any issues or just want to talk at any time, again, my email is bdevine@solesca.com, or you can just use this contact form here, and we'd really love to hear from you. So again, thanks for choosing Solesca, and we're looking forward to working with you.